Hi everyone! In today's video I'm going to talk about exact ODEs, and I'm going to start off by writing some definitions up on the board. I'm going to work through some examples, and hopefully by the end of the video it's going to become clear the strategy behind these problems. So let's get started. An exact ODE has the following form. We have n of x and y plus n of x and y times its derivative is equal to 0. And this m of x and n of y are just two functions of x and y. However, we need to double check if the ODE is exact by doing the following test. The partial derivative of this function m with respect to x needs to be equal to the partial derivative of this function n with respect to y. If we find these derivatives and we see that they're equal to each other, then we could say, yes, the ODE is exact. So we can say that it's exact with certainty. And the way we can solve, the way we can proceed our analysis is by doing the following. So I'm going to define a function called psi, and it's going to be the potential function. This concept's a little bit abstract now, but it's going to become very straightforward when we start doing the examples. So we have a function psi. So this is the Greek letter psi, and this is called our potential function. And the nice thing about exact ODEs is that the potential function in terms of x and y is equal to a constant, and that's going to be our solution to our ODE. But how do you find this potential function psi? Well, we know that its derivative, so psi with respect to x is equal to m of x and y. So, and then the partial derivative of psi with respect to y is equal to n of x and y. So, what we need to do to find psi is to integrate both of them. So, psi is equal to the integral of m of xy dx, and psi is equal to the integral of n of x and y dy. And we need to find both of them. We can't just say, oh, psi is equal to this, and therefore I'm done. Psi is equal to a constant, I'm done. We need to evaluate both integrals. This integral of m with respect to x and the integral of n with respect to y. And the reason is because when we do that, so I'm going to erase this so I could continue. So when we find this, when we evaluate this integral, we're going to have like the integral, the expression, and then our constant. But our constant is going to be a function of y. Because when we're taking the partial derivative with respect to x, it's going to be 0. So this is just a constant. And similarly, we have our integral of n of x and y with respect to y. And when we evaluate this, we're going to get an expression plus a function of x. And this function of x here is constant. So basically, this function of x is going to be all this meat over here. We need to be careful, but when we solve examples, it's going to become clear. And the function of y is going to be somewhere over here. It's not going to be necessarily all of them, but it is going to be there in both of the cases. And then, once we find our function psi in terms of x and y, we could say that this is equal to c. That's a theorem. And it really helps us, like, makes our lives easier. So when we say that the potential function is equal to a constant, then we're basically done solving the ODE because we're gonna have an expression. We're gonna have an expression is equal to a constant, and that's gonna be the implicit solution of the ODE. And then if you want, you just solve for y and to get the explicit solution of the ODE. So very abstract for now, but let's do a couple of examples that it's gonna become clear. Everyone, so just a small little note before we go. I made a mistake when writing out the test for finding exact ODEs, and this is the correct version. It is the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. On the video, I wrote it like this, x, and here y, but that is wrong. That is wrong. The correct version is partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Again, I apologize. This is the correct version, and we're going to solve some examples. It's going to really clarify all of the material. Thank you for watching. If you have any questions, please leave it on the comment section below, and I will see you next time. Bye.